Hello, grade 12. So today we're going to focus more on isomers, right? The first thing that we should go through is the definitions. The definitions are examinable. So please know this definition and write the correct words because these are easy free 2 marks. So the definition of isomers are molecules that have the same molecular formula. But what is molecular formula? So molecular formula shows the number of atoms in each element of the molecule. So molecular formula e bontsha number ya di-atom tsotlhe, like in each of the element, right, in a molecule. So yeah, moving forward, we have structural isomers. Structural isomers are molecules that have the same molecular formula but different structural formula. Ena it means hore that's one ka molecular formula, but ka structure they are different, right? So moving forward, we have isomers with the same functional group. Please note, do not confuse the word functional group and functional isomer, right? Those are not the same words, and they have different definitions. So functional group is a characteristics of a certain homologous series. Other definition for functional group is that is a bond or group of atom or an atom that determines the physical and the chemical properties of homologous series. Guys, please know your definition by heart. These are easy 2 marks. So under isomers with the same functional group, we have two isomers. It's structural isomer and positional isomer, but we will be starting off with structural isomer. Um, Under structural isomers, they have the same molecular formula but different structural formula, right? I have two structures here, for example, and I will explain why we say they are structural isomers. The first thing that you should know is that these two structures belong to the same homologous series, right? Uh, it means they have the same functional group, right? So these are all single bonds. These are all single bonds, but this is a straight chain, and this one has an alkyl group, which is a branch, right? So the name of this structure, it's butane. Butane. It's butane because we have one, two, three, four carbons, and the name of this structure, we have one, two, three, but we have an alkyl group. So it's 2-methyl, 2-methyl. It's 2-methyl, 1, 2, 3, propane. If you're still encountering difficulties with naming, just go back to the previous video of IUPAC naming and ace how to name these structures. So why do we say these two structures are structural isomers? As you can see, we have 4 carbons. It's C4. How many hydrogens do we have? We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. H10. Right? How many carbons do we have in this structure? 1, 2, 3, 4. You also count the branch, right? It's C4. How many hydrogens? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. H had 10. So that's why we say they are structural isomer, because they have the same molecular formula but different structural formula. This one is a straight chain, and this one it has a branch, which is an alkyl group. So the next isomer with the same functional group, we have what we call positional isomer. There are two, right? Under isomers with the same functional group, we have two isomers. It's structural isomer and positional isomer. So positional isomer are molecules with the same molecular formula but different position of functional group or bond. It means the functional group or the bond changes their position, right, on the chain. Please note that the parent chain stays unchanged. I've highlighted using the asterisk. Please note that the parent chain stays unchanged. So we have an example here. It's prop 1 all and prop 2 all. As you can see that, why do we say that these two structures are positional isomers, right? Because as we can see, the functional group are the same. They belong to the same homologous series, right? They belong to the same homologous series. They have the same functional group. But know that the functional group of the OH, the hydroxyl group, have changed. On this one, it has bonded on the first carbon, and on this one, it has bonded on the second carbon. That's why it's prop 2 all, prop 1 all, and prop 2 all, or propan 1 all, and propan 2 all. That's why we say these two structures are positional isomers, because their functional group have changed the position. And please know that the parent chain stays unchanged. It's 1 2 3 1 2 3. It's prop on the side, and this is also prop on the other side. Another thing that you should know, that these two structures are positional isomers because they have changed the position of the functional group have changed, right? On this one, it is bonded on the first carbon, and on this one, it's bonded on the second carbon. They have the same molecular formula. How so? They all have three carbons. It's C3, right? How many hydrogens? 1 2 3 4 5 6 7 8, right? H8 and one oxygen. How many carbons? We have 1 2 3. How many hydrogens? 1 2 3 4 5 6 7 8. And how many oxygen? We have 1. They have the same molecular formula, but the position of their functional group have changed. Another thing that you should know, that these two structures are positional isomers because they have changed the position of the functional group have changed, right? On this one, it is bonded on the first carbon, and on this one, it's bonded on the second carbon. They have the same molecular formula. How so? They all have three carbons. It's C3, right? How many hydrogens? 1 2 3 4 5 6 7 8, right? H8 and one oxygen. How many carbons? We have 1 2 3. How many hydrogens? 1 2 3 4 5 6 7 8. And how many oxygen? We have 1. They have the same molecular formula, but the position of their functional group have changed. So moving forward, we have isomers with different functional group. It means we are comparing structures from different homologous series, right? Under isomers with different functional group, we have only one isomer. It's functional isomer, guys. And please do not confuse the word functional isomer and functional group. Functional isomer, it have the same molecular formula, but different functional group. They have the same molecular formula. Have the same number of atoms in each element in the molecule, but different functional group. What is functional group? Is a bond or an atom or group of atom that determines the physical and the chemical properties of homologous series. Please know your definition by heart. That way, you are guaranteed that those definitions you are going to score them, right? You are guaranteed of those easy 2 marks. So functional isomer, I have a homologous series here. As I've mentioned earlier in my videos, that carboxylic acid and ester have some certain kind of relationship. So this is where we discuss their relationship. And also the aldehyde and the ketone have some certain kind of relationship. So you have been asking yourself, what is that relationship they share, right? This is the relationship they share, is that they are functional isomer. Carboxylic acid and ester have the same general formula, right? And aldehyde and ketone have the same general formula. It means they have the same molecular formula, but they belong to different homologous series, right? Carboxylic acid, and ester, the functional group, it's CnH2NO2, right? And the general formula for the aldehyde and also the ketone, it's CnH2NO, right, with one oxygen. So, guys, please know this. Carboxylic acid, always, the functional group of carboxylic acid, it will always be the ester. Please do not write the alcohol, or no, you are contradicting yourself, right? The functional isomer for the carboxylic acid, it's ester. The functional isomer for the ester is carboxylic acid. And also, the functional isomer for the aldehyde, it's the ketone. The functional isomer for the ketone, it's the aldehyde, So we are going to go through an example and show you how this two homologous series have a relationship, which is the functional group, how they have same molecular formula, and as I've highlighted, they have the same general formula, but they have different functional group. So guys, I have examples here under functional isomer. I have erased the definition just to get a little space, but just know functional isomer have the same molecular formula but different functional group. As you can see, isomers with different functional group. So ester goes along with carboxylic acid, right? So this is a relationship they share. It means they have the same general formula. What is the general formula for this two homologous series? It's CnH2NO2, right? This is the general formula for this two homologous series, which is the ester, and this one is the carboxylic acid. This is the relationship they share. It means they are functional isomer. So on my example, I have propyl methanoate and butanoic acid, right? So how many carbons do I have in this homologous series? It's 1, 2, 3, 4, right? It's C4. How many hydrogens? 1, 2, 3, 4, 5, 6, 7, 8. H, 8. And 2 oxygen. O2, right? How many carbons do I have in this carboxylic acid? It's C4 from butane, right? Butane. 1, 2, 3, 4. You might as well count them. How many hydrogens? We have 1, 2, 3, 4, 5, 6, 7, 8. H8, right? How many oxygens? 1, 2. There are 2 oxygens. So, easy peasy lemon squeeze, right? They share the same general formula. It means they have same molecular formula but different functional group. Remember, the functional group, they have different functional group, right? They belong they belong to different homologous series. This one is an ester, and this one is a carboxylic acid. Another example of functional isomers, I have butanol and butane 2-O. This is an aldehyde, and this one is a ketone. Remember, ketone and aldehyde are functional isomers because they have the same molecular formula but different functional group. It means they belong to different homologous series. So this one it's butanol, this one it's butane 2-O. Their relationship is that they are functional isomers, and the general formula it's the same. It's CnH2nO. This is the general formula for the aldehyde and for the ketone as well. So let's prove whether they have the same molecular formula. We have 1, 2, 3, 4 carbons. It's C4. How many hydrogens? It's 1, 2, 3, 4, 5, 6, 7, 8. H8 and 1 oxygen, right? And 1 oxygen. So on butane 2-O we have 1, 2, 3, 4. C4. And then how many hydrogens? 1, 2, 3, 4, 5, 6, 7, 8. H8, 8, and 1 oxygen, right? So there's an imaginary one here. So this is their relationship, but they both have same molecular formula, right? They both have 4 carbons, 8 hydrogens, I beg your pardon, and 1 oxygen. They have the same general formula. So this is the relationship. So guys, please know your isomers. They're very easy if you give them time, and they're very understandable, right? So know your isomers with the same functional group, which we have two. It's structural isomer and positional isomer. And isomers with different functional group, it's one. It's only functional isomer. So, and under functional isomer, the homologous series that we use, it's carboxylic acid goes along with ester, and aldehyde goes along with ketone, as you can see from the previous videos. So guys, please do practice and also know your definitions as well to score yourself some easy 2 marks, and know how to apply, and also read the question thoroughly and understand them and answer them properly.